Say again?
I'm aware.
Okay, so quick couple of notes because I forgot to talk about it yesterday, and I know y'all are gonna have time to talk about the projects a little bit later with your small group or with your project group. However, someone asked yesterday what the P and the B stood for in the STEM article. And so the P actually stands for something called a p-value. The B is actually for slope. Don't sweat those two things yet. Those will be literally the second half of this unit, or of this course. What I will say is, remember, your whole focus is on the study design. So like, is it an observational study or is it an experiment? What did it do to reduce bias or reduce confounding or all those things within those projects, okay? So, please get it out. Okay, and now see these questions over here. It's interesting, I'll just love to write the questions on that board.
Because it used to be split between like its classes.
Any board you want.
I'll write it over there.
Yep. I mean, as long as you put an asterisk, I've mostly started to look over here because that's where you always put questions. Okay, so someone already asked, I know, about a uniform distribution. So a uniform distribution, that's one of the shapes. That's a shape for quantitative graphs. Or quantitative data, I should say. So here is what a uniform distribution would look like.
Oh, okay.
So symmetrical.
It's not just symmetrical, because I will point out, this is symmetrical, right? This is symmetrical. Even this is symmetrical, but only this one is uniform. What do we mean by uniform?
It's one of the.
It stays the same. If uniform, it just means that it stays the same all the way across.
Is it still considered symmetrical?
Yeah, it is symmetrical. I was just showing that, yes, approximately symmetrical. I was just showing that symmetrical is not always uniform. Uniform is always symmetrical, but not the other way around. Just like a square is always a rectangle, but a rectangle is not always a square. Yes, mosaic plot, yes.
Wait, I need to
So is this basically the unit model?
No, because there's actually no mode at all. Uniform means it stays the same, like that's what the word uniform means. This would be unimodal because it has one mode, one peak in here.
What would the fourth one be then?
Wait.
This one down here?
Yeah.
Yeah, I've never seen anything like it,
So
I've
what do
made
we
it
like
up.
explain like uniform, like when we're like describing the shape of things?
Say that one more time.
Like do you like include like the uniform?
If that's the shape, I can go ahead and tell you, uniform is not a common shape.
Okay.
Yeah. But yeah, if you see, that's some really interesting statistics there, Phoebe. Wait. Oh my gosh. So, uniform is just a shape. Yes.
So if a question like asks if it would be uniform, how would you like?
Say that one more time.
I don't remember what the question was.
Was it from the progress check?
Because there's like two questions that had that as an answer, and I didn't know what that meant.
Yeah, it's very uncommon. Again, like, that's uniform. By the way, if you're like progress check, what they did, Sophie and Star went ahead and did the next one is due. It's not due till tomorrow. But I think they thought it was due already. You're good. I just unsubmitted it so you can go back in and look at your questions again. Huh?
Was it that unit one?
Yes. Progress check A. Yeah. Yeah. It's due tomorrow night. Okay. Yeah. So, but Sophie, if it's just asking about a shape, like it has to look like that to be uniform. That's it. That's the only uniform shape. It just means it's the same all the way through. Okay, I saw someone, where can I find, okay, the answers to the homework, yeah, I was a little sad when I tried to send an email around 4 when I was about to leave here. I was a little sad when I realized that there's no way any of y'all were doing the homework and checking yourself because I thought I had put the solutions up, but I hadn't. They are up as of 4 o'clock yesterday. So, guys, if I forget to upload something, please let me know. They are on Schoology though. Solutions are on Schoology this morning. What up? You?
Oh, yeah.
Go ahead.
We did go on that after.
Yeah, but before yesterday at 4 o'clock, there was no way. But if it was after 4, yes. So I'm guessing whoever asked that question was doing the practice and checking before 4 o'clock. So that's my bad.
No, actually, it was after 4 o'clock. I don't know.
It-
Maybe I was supposed to.
It's up, because, unless I'm wrong, but if you go
It might have not
to,
clicked on the right file, because it just says AK after it, it has
I
an
clicked both of it and I went into both of it, maybe,
let's see, if you go to Schoology, and, so we're in Unit 2, right?
Yep.
And then
yeah, I got that.
homework assignments and solutions. Yeah, AK has the solutions.
Actually, okay,
Yep,
maybe I was making
There's the
it
answers.
early.
okay?
Yep.
So they're up.
Thank you.
Not until after 4 o'clock yesterday, or at 4 o'clock, my bad. Let's see, other quick questions. Where can I find information on the Frere model? It was a little confusing. Yeah, in the old textbook. If you have one of the old textbooks, and I need to check first thing tomorrow with Mr. Hinton to see where extra textbooks are. If you have the old textbook, let me know and I'll look at it. It is Unit 1, I know, in the old textbook, that has information for the exploring one variable data. Okay, so it's Unit 1 in each of the textbooks, but there may be some small things. One of the old textbooks may not have anything about mosaic plots, because that was not added to the course's study, not course study, the course exam description until 2020 or 2024.
It's just one we got on the,
Yeah,
no.
so, okay, so there's that. Can we go over conditional, marginal, and joint relative frequencies? Sure. How do we answer the question? Oh, that's sad. It's starting to come off. How do we answer the
Oh,
question when if asked how much wider the graph is? I gotcha. So that's a mosaic plot question. Explain how to do frequency, mean, and median, okay? Is it frequency or relative frequency that we're asking about?
okay, Mom's right.
The frequency, mean, and median?
Yes, it is.
Okay.
Yep.
So I looked at the video and I'm so confused
Okay,
about
that's fine.
frequency and national and how
Well, frequency is just how many times. Do you mean relative frequency?
No, not relative frequency. I don't know relative frequency, because that's just like frequency.
Yes.
But frequency, I don't understand that at all.
Well, you just collect the data. It's how frequent the thing comes up.
Okay, that's,
Huh?
that's what Google said.
Yeah, that's right.
But
Yeah.
it's sort of.
It's also in the textbook, so don't forget to look in the textbook. But, so I'm going to come back to all that in a second. It says, can you go over 3.1 multiple choice? Is that supposed to be 1.3?
Yeah.
Okay.
Yeah.
Yeah. I was like, we haven't gotten to you get to 3 yet. All right. So I'm going to start with pulling up some of the. Unit 2.
The second part.
Practice. Okay, so there's that. And you said 1.3. Okay, so let's actually do mosaic plots first, to tackle that, and then we will tackle, by the way, when we do the DYU, do not let me forget to put a graph up on the board so that you can see the colors. Okay, so mosaic plot. So what I want to point out is this. So we looked at this problem yesterday. This is not a mosaic plot. How do I know it's not a mosaic plot?
Because
It's
they're
not
separated.
So the bars are equal width. The separation is also a good hint. But the bars being equal width is probably a good indication it's not a mosaic plot. It is in fact a
Segmented bar graph.
segmented bar graph, okay? So, here's the thing, and I'm gonna make this up here. Let's say that urban students or urban people, I had 200 of them, okay? Suburban, I picked up 100, or I surveyed 100 people. Yeah, let's go with 100. And then, let's do that, 250, because they're really densely populated. So 250, 150. Okay, so that's the frequency. And so, Lorelai, when you're asking about frequency, that's just, there's 250 people that were in that urban context, right? So when I now try to make this into a mosaic plot, how many total people did I collect data from? Respondents?
400.
400. So the width for the urban in the mosaic plot would just be, so, is that 62.5%? Can someone do that calculation for me real quick? I think that's right.
I think so.
Well, it'd be 0.0625.
Yeah, 1.25 times five. Wait, why did we
Yes.
take it home yesterday?
Something like that. Guys, y'all got calculators? Just type in 250 divided by 400. Get it
Yes.
done.
I'm trying.
TS is there.
0.625. Okay. So, if I'm talking about the width, what
Thank you.
percent of the width, or what fraction of the width should the urban group be?
Oh, more than half?
More than half, and it doesn't have to be perfect, technology will make it perfect, but 62.5% of the width would be urban, because we interviewed so many more of them, right?
Right.
Suburban individuals, that was 100 out of 400, so that should be 25% or 0.025, but 25% of the width of that mosaic plot. Okay with that?
Wait, what do you mean 25% of the width?
So, remember, in a segmented bar graph, the bars are the same width, right? But if I were doing a mosaic plot, I need the width to indicate what percent of the respondents were in the urban setting. So, let's say this is halfway through, so 62.5%. So, this would end up being the width for the urban group, because 250 out of the 400 residents or respondents were from urban setting, right? And then a quarter, right, 100 of the 400 were from suburban, right? And then the last 12.5% would have been from,
Rural.
okay? So the segmented bar graphs would stay the same, like this width for the rural, or like this height here for the rural would stay the same. But now for the suburban, this is what the suburban would look like. Right? And then the urban would be this group. Notice the same heights for each of those groups, but the width of the mosaic plot changed based on how many I had from the urban, the suburban, and the rural context.
So in the same homework section is it 1.2?
There's 1.2, yeah.
Yeah, and the number 4, there is like a similar question that I was confused of. So there's a question in B called, the number of students enrolled in some of the AP calculus are same level as high school B and high school C. So shouldn't it be false because it's a percentage? So if you don't know how many people they surveyed on high school A, B, C.
Well, it says which of the following must be true.
Yeah, and B and D, I think they're really comparing the different high schools' results.
Wait, so you're saying which ones are false?
No, and B and D, I was confused about true and false. because-
Okay, so B says, so we're only looking for what must be true. B says the number of students enrolled in AP Calculus is the same for high school B and high school C. Now, I just want to stop and I do want to point out,
There's students.
a segmented bar graph never shows the number.
Yeah.
What would you need in order to know the number of students?
The total?
You would need to know the total along with that segmented bar graph. So like for me, I haven't read everything, but I would eliminate A and B because I don't know about the number of students. I only know about the relative frequencies. Okay? So, for high school B, more than half the AP math course enrollment is for AP pre-cal. What does that go from 35? So that's not more than half. So C is out. There were fewer students.
Which was yeah.
So D says there were fewer students enrolled in AP pre-cal at high school C. So AP pre-cal, right? High school C than at high school A. But here's the thing, I don't know how many students unless they have the same population, right? This has a fewer proportion or relative frequency of students in AP pre-cal, but I don't know that. Now I will say, I can make a conclusion about E, right, because it is only looking at which high school? C. So I can't compare the different high schools unless I have a mosaic plot, right? Because then I can look at the areas. But in E, there were more students in AP Stats than AP Cal. That's actually not, wait, which one was Stats and Cal?
Stats at the bottom.
Stats is the bottom one. So yeah, there's definitely more here because that's a bigger bar than here. So like I can compare within that one school. I cannot compare across schools unless I know, I can't compare numbers across schools unless I know the total number of each school. So there's a higher relative frequency here than here. But for the most part, a segmented bar graph, you gotta remember, has a percent or a relative frequency.
So the A, B, and D automatically eliminates themselves because it's comparing the number of students of the two
Different
bars.
schools. But again, if we had the total number in each school, then I could determine that,
Yeah.
right? So it's like if, and again, they didn't have this, but in high school C, if they had told me that there were 500 students in high school C, or seniors, no, students, 500 students enrolled in AP classes there, then that would be roughly, and this would be an estimate, but it'd be roughly 40% of 500. Right, so remember I bring this up because some of us were like, I'm not comfortable with percents. Pay attention to this, right? If it's roughly 40% of 500, it's just 0.4 times 500. And that would tell me how many students, but I would have to know how many total there are. Okay? Sound good?
Yep.
All right. From there, someone was asking about the relative frequencies, right? And then we'll move to Madeline's question. Was that in lesson 1?
Yes.
Is it 1.1?
Yeah.
Okay. So yeah, here we go. So yeah, pay attention to this because this, I can go ahead and tell you, this is definitely in your assessment. You got to know these different types of relative frequencies. So again, you were asking about frequencies. These are the frequencies. So there's 386 people that preferred streaming and were less than 45 years of age. Like that's what that's saying. It's saying there were 306 people who preferred listening via streaming and were more than 45 years old. Okay? We good with all that? So then when I look at say B here, you gotta be careful and read it. So what percent of all adults? So am I looking at just a subset of the adults or all the adults? All the adults are 45 or older, okay? So which category am I, or which variable am I looking at?
The right.
So, well, which variable?
95 CDs.
Hold on, which variable? Age. And then which category?
Over 45.
Over 45, right? So I'm trying to break it down. And they prefer listening to CDs, okay? So whenever it's an and, does anyone remember the name of that type of relative frequency?
A joint.
It is joint, because it's where we have both. It's 45 plus and CDs, so it's where we have both. When it's both of them, it's the and. So that is a joint relative frequency.
Isn't it?
Why?
And hold on one second. So remember, relative frequency, we take that frequency, so 95, and we divide it by however many adults were there. How many adults were there?
1576.
1576. So I will point this out. You can leave it as that fraction, or you can get the decimal. If they ask for a percent, do convert it to a percentile, right? So this actually does ask for a percent. I typically leave it as a relative frequency, as a fraction, or as a decimal. Kenzie and then Raina.
Okay, so quick question.
Yes, ma'am.
So joint is the 95, like, because you're doing 2 in a column. Marginal is like, I don't know, it says B and C on my thing, so like you add.
So let me pause you for 1 second. Let me just point this out. Joint is whenever you're looking at categories for 2 variables at the same time. You see how these categories are joining together? So whenever it's one variable or one category and another category from 2 different variables, it's where they join together. So it's joint. Does that make sense?
Yes.
Now, I'll point this out. Right now, I don't have any of the margins done. I would personally, if I ever have a question like this, I would actually do my totals really quickly and find those to help me out. So 386 plus 306 is 692. 138 plus 389 is that 527?
Yes.
Yes. 124 plus 109 is 233. 29 plus 95 would be 104.
124.
That's what I meant. Thank you. So glad y'all are here. That would have been bad. All right, I don't know this column off the top of my head. 677.
What? 899.
What is this one?
899.
899.
Yes.
And so notice my total is the 1576 you talked about earlier. So notice, Kenzie, how by looking at this category for this one variable, I got a frequency in the margins that's outside of the original table. That's why we call it a marginal relative frequency, because notice I'm not looking at two variables, I'm only looking at one. So when it's only looking at one variable, that's a telltale sign that I'm looking at a marginal relative frequency. Does that clarify those two? Okay. All right, so get your percent off of that. See what percent of all adults, again, all adults surveyed preferred listening to the radio. Notice how many variables am I looking at? One, and I'm only looking at one category within that one. Now, I will point this out. Could they have said listening to the radio or streaming? And notice that's still going to be marginal because it's only one variable. Even though it's two categories within that one variable, it would still only be one variable, it would still be marginal. It only asked radio, so find the percent, so that's marginal, but find the percent of 527 divided by 1576. Yes, Dixie?
So like, when it's a conditional relative frequency, would it be like given, will the question be phrased like this, like given this?
A lot of times yes, but not always. I'm going to show you the quick thing, the way to always recognize it right here, okay? Just in case we've got it. Notice how I've always pointed out all students, or all adults. This is looking at everybody in the club. What does it say right here? So am I looking at everybody in the club anymore? So if I'm ever only looking at a subset of the sample, that is going to be a conditional. Because I don't care about everybody. What condition has to be satisfied? Do they prefer streaming? So I'm only looking at this group right here. Notice that's a conditional statement. So a lot of times it has a given. When we talk about probability, it'll almost always have a given. But if it does say this, like I'm not looking at everybody, I'm only looking at this group, that's a conditional relative frequency. So of the adults that prefer streaming, what percent are less than 45? So I don't care about everybody, I only care about streaming and which one's inside of the streaming. Less than 45, so how many is that? 386 out of?
692.
692.
55.7.
So get that decimal and then convert it to a percent. Does that clarify those things? Cool. Okay. Final mosaic plot histogram. Oh, and then Madeline's questions too, right? Gaps and clusters. Yep.
Actually, I don't think that I need to do mosaic and histograms, but Emerson circled it, so.
No, I didn't.
Oh, are you embarrassed to say that you don't know something? It's really okay, Emerson.
No.
Oh, okay. Okay, so 1.3 multiple choice and, you said 1.3 part C?
You just called it a
number
keyword.
3 parts.
Number 3 part C.
Sorry.
You're good.
My brain is off.
You're good, you're good. Okay, so number 3, part C. So describe the shape of this distribution. So first things first, I do want to point out, this one is a little bit tricky because stem plots are not the same as how we would normally look at it. But I want you to recognize if I were to make a dot plot, right? Wouldn't I go 60, 70, 80, then 90? So picture this flip to here.
Oh.
It would look like this, wouldn't it?
Ah.
See how this would fit inside of that? So picture it, rotate it, and then you can see the shape more clearly. Why do we use stem plots? If you remember, I even said that. I was like, it's in the AP stats thing, but I would never do it. I will say a stem plot is good for seeing individual data values well, but I'm not And I will say this, in the not 21st century, in the 19th and in the 20th century, when we didn't have vast sets of data, stem plots were probably really good. But with the way that the internet is, like, there is more data generated every, I want to say second, than like the first couple millennia of the world, because of the way we consume the internet. Like, I need to go back and look at that, but I got a chance to like work on a position writing team one time about whether we should accept data science in the high school classroom. Like, it was a really cool national thing. But we talked about the fact that like there's more data being generated every second today than there ever has in all of history. And so with that kind of data being generated, it doesn't make sense to do this.
And there's a lot of, examples, it'd be hard to put all of
Right, okay. But does that make sense of how we would then, so like what would I say about that distribution?
I said it skewed to the left.
I mean, look, there's 3 data points here, right? And there's 4 here. And like if I were to draw, what does that look like?
Symmetrical,
That looks pretty symmetrical to me.
approximately.
Approximately symmetrical. That's why I say pretty symmetrical. It needs to be a pretty long tail for you to go skewed. So I would say approximately symmetric. What else should I say about shape? And unimodal. Okay? Now, one thing I do want to remind you is when you are asked to analyze a quantitative distribution, what do you got to put in there? Cuss
And context.
in context. So you got to have center, unusual shapes, or unusual aspects, shape, and spread. Now, someone asked about gaps and clusters. So let's say, for instance, that we had this set of data, and then we had no data at all. Oh, let's not go that direction. Let's go this direction, because I don't want to get into the hundreds for degrees Fahrenheit. Let's say we have no data at all, and then it has a hump like this, okay? What do we have right here? A gap, right? So we would just say, hey, there's a gap in the high temperatures from 50 to 60. And then we would say that we could say there's clusters around 45 degrees Fahrenheit and 75 degrees Fahrenheit. That's it, right? When we say clusters, we're talking about those modes there. So it is clustered around 45 degrees Fahrenheit and 75 degrees Fahrenheit. There's a gap between, or for the highs, between 50 and 60. Yes, ma'am?
Can you explain how to do mean and median? I know when you use it, but like, I just don't understand how.
Well, first off, don't forget, you got a calculator.
Well, yeah, I have a calculator, but I don't know how to put it into it.
I don't know what to put in there.
You just put the data values.
I don't know what they should put in
Can
So-
you give an example?
Yeah, let's use this data right here.
Yes.
there. I'm not
Okay.
saying-
So grab your calculator. Now, I do want to remind y'all, okay, because we do, as an AP stats class, we got to move somewhat quickly. I'm more than happy to answer your questions, but don't forget, like, I get here pretty early. Like, I think I'm here by 7:15 almost every morning. Even this morning I was late, and I was still here by 7:25. First block is my planning. I'm more than happy to help people during either of those times. Okay, so here's my list and spreadsheets page. Okay, so make a list of spreadsheets. Make sure you label your variable. So let's just call it temp. Okay, so there's my temp. And then let's put the data values in here. So, okay, so there they are. So 63. 66, 68. Remember, this is why it's important to have a key in there so that you can read it. Say again.
Can we go to the chart?
The list and spreadsheets that I'm doing right now?
Yes.
So remember, once you have a document, hit Control Doc and add a page. Or to add a new page.
Oh,
Don't forget, help each other in your small groups while I'm putting this data in.
I just put temp in first.
Yeah, put them up there and there's the orange.
Star. Don't get into their silly
63. It was a genuine mistake. I did on accident.
Sure.
Okay.
Sure, Star.
So you do.
Okay.
It flows off the tongue.
Wait, so you do.
I hope not. I hope you're not used to DUIs or anything, but go off, dog. All right, so just put that data in there. Now, I will say this. I'm about to walk through it quickly. Don't forget the data's right there, okay? So pause for a second. I'm going to show you a couple things in a second. But look, once you have your data in, so Lorelai, just pause for a second. Once you have your data in, what's the button that does cool crap on each calculator?
Menu.
Okay, so I'm going to go to menu. And what from there?
Statistics.
I'm going to go to statistics, right? Under statistics, I need stat calculations. And I have one variable, right? So I'm going to say, okay, put your variable in here, the temp, and just hit okay. And if I go up, you gotta go pretty far up. What's right here?
The median.
Median, right? The median's given. What's all the way at the top?
The mean.
The mean, it's given.
Where is the median?
It just says.
Just scroll down, it says it.
Oh,
Right, there it is, 81. Okay, so notice, like, it tells you those values right away, okay? Now, I will point out with this data set here, if I want to find the median quickly, that's another benefit of a stem plot. What does a median do? It separates the
Bottom 50%.
bottom 50% from the top 50%. So, right here, if I have 30 data points, which I do, how would those 30 data points get split up so it's 50-50?
You get the middle two and you get.
I need
15.
15 and 15. I gotta start there, Star.
Oh, we're.
Right? I gotta split it into 15 and 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
No.
Okay? So it's gotta be between 81 and 81. And what's the only number between 81 and 81? 81. That's my median.
But shouldn't you, when you calculate the median, shouldn't you list it above like the smallest one?
Well, first off, stem and leaf plot's already listing it from smallest to largest. What you're talking about is a traditional algorithm, but you don't have to have it listed all the way out to find the median. The calculator doesn't need that. All you need is to separate the bottom 50% of data from the top 50%. If you can find the value that does that without listing it, you don't need to list it. The listing is fine, but it's already here. If I have a dot plot, I don't need to list it. I just find the bottom 15 data points and the top 15 data points. And there's my median, okay? The one thing to think about is, let's say you have, you good there, Ian? Let's say you have 31 data points. How are you going to split the 31 up?
15.5.
But you can't split a data point in half.
And then 1,
And then 1, and then,
15.
so when you have an odd number, it's just whatever that 1 in the middle is. Okay? But again, by the way, do we have to do that by hand? No, use a calculator. Do you need to conceptually understand what a median is? 100%. Okay? Now, last thing, a mean. We need, what's another word for mean? Because I think that's throwing some of us off. Guys, the mean is just an average. The arithmetic mean is just an average. So that's just where you add all your numbers together. And then we're going to divide by how many numbers?
The size of the sum.
The number of numbers, right? Yeah, 30. That's the formula. And I'm going to give you the formula for the quiz. But it's the sum of all my x values divided by the sample size. But again, do I have to do that by hand? No.
No.
Got calculators. Okay. We do have time to do the DYU before we go to lunch. Is that all the questions, I think? Yes. Oh, the multiple choice.
They're all, you were talking about stem plots or
No, wait, I think we just do it.
and it was just asking which one's not.
So this one right
I
here?
don't know, I thought it said it was on.
I got you. So number 7, right here, guys. Sylvia's wondering how many hours students are working at jobs each week. She surveys 100 seniors and records the number of hours they worked at a job in the past week. So first off, why would a bar chart not be a good option?
Because this is quantitative data.
It's quantitative data, right? Bar charts, categorical. So not using that. Now, could I use a stem and leaf plot?
You could.
I could.
But you know what,
That takes
That's
up too much
100
space.
data points. That would take forever, right?
Yes.
I'm not using a stem and leaf plot. Could I do a dot plot?
No,
No.
yes. But
I could, but I'd have to do
That'd
100.
take forever.
Take forever. Histograms are best for large data sets. is the big idea there. What I will make a note of, which would not be a good way.
Oh, a bar chart.
A bar chart.
So these following displays would not be a good way to display her results.
A bar chart.
A bar chart, I guess if we're only looking for one answer, it has to be a bar chart. I personally would not do a stem and leaf or a dot plot. Granted, if I have the data in technology, like a calculator or a computer, those can easily make dot plots and stem and leaf plots. Okay? Does that make sense?
Yes.
Okay. So a bar chart would not be acceptable because that's for categorical data. Was that the only one you had a question about?
8 is a little different. It was like,
Oh, there's no way to tell. Yeah. Yeah. So you could do the mean, because here's the thing. We know that the mean of these 17 is 11.2. So if I do 17 times 11.2, that's the total weight of all the macaroni penguins. If I do 10 times 31.9, that's the total weight of the king penguins. And then I have a total of 27. So that is called a weighted average. So I can find the mean that way, but there's no way to find the median unless you have the actual data points. Yeah. So I can do the mean, I just can't do the median. By the way, just to help a couple of people that I heard talking about this earlier, would this be discrete or continuous data?
Continuous.
How do we know it's going to be continuous?
I mean,
Because they're weights. What do we have to do with weights?
measure.
We have to measure them, and so we're going to end up rounding, right? So your weights are continuous data we have to measure, so we'd end up having to round. Okay. Oh, let's do this. The last 9 or so minutes, why don't you get together with your small group and we'll take this time to talk about projects. Have we all actually read?
I started.
Okay.
How about I take the time to read
Did
it?
you read the assignment list?
Yeah, I read
Okay.
the
So let's,
I'm
guys,
halfway
you
through the second.
have to read before we can talk. And they're due Sunday. So I'm gonna give y'all time tomorrow then to talk. You need to finish reading. Yes, Leah?
Do we have to, do we highlight on this, or do you?
Yeah, it's yours.
Oh.
Yeah, you're right, guys.
You better be here tomorrow.
So, Rip, discussion point, what you're supposed to do. One of them is an observational study, the other is an experiment. Oh, I didn't give you all the rubric I have for this, do I?
No.
You just gave us.
Yeah.
You gave us the pencil.
Let me get the rubric for you. So I'll print that out during lunch. But you need to identify which one's an observational study, which one's an experiment. You need to talk about the goals of it, right? So the goal in general of what an observational study is and what it is specifically for that study, right? So you have to identify which one's observational, which one's experiment, okay? After you identify what type of study it is, what the goals of the study are, then you need to, if it's an observational study, what had to be reduced. So you need to talk about what was done to reduce bias, okay, to be able to make the proper inference. And then finally, I want you to end with what you could do to improve the study. So what could be further done to reduce bias, or maybe even get into the ideas of causation. So like if you're like, man, this is a good observational study, but I could determine causation if we made these changes. So just in general, what would you do to improve the study? Use the study design ideas and motifs. With the experiment, again, what are the goals? Like we need to know cause and effect, but like what's the cause and what's the effect? What's your explanatory and response variables? So use as much of the vocabulary as you can in talking about it. Like in that experiment, what's your explanatory? What's your response? What's the causation that they're looking for? What are potential confounds, right? So what do they do to reduce confounding? And then what would you do to improve the study? Does that make the directions make more sense?
Yes.
Yes.
Like
Yeah,
an
so
example
you
of
want
one.
to show some examples.
Like, I'm just wondering, like, the format of, like, the paper, actually, so I can start.
Yep, that would make sense if I had actually remembered to do that. Well, I'll put several on Schoology for old ones because I'm using different studies than I've done in the past, so I will put some up. But I'll also print some out for y'all to look at. I don't want to make this due in the middle of the week because I don't want to compete with other stuff, but because I forgot to print those things out, I might have to make this due. Oh, we have Monday off even, don't we?
Yeah.
Yeah, it's Labor Day. What if I make it due Tuesday night so that you have the whole long weekend and then Tuesday as well? Does that sound fair?
Thank
And
you.
then I'll try to get the rough drafts with feedback done through the rest of the week and back before the weekend, or at least at the end of the next weekend, and you can do a final draft. Yes,
You want the rough draft type, right?
yes, please, do not handwrite that.
Oh.
Yes. For two reasons. One, I don't want to read handwriting. Two, I'm expecting you to make edits based on feedback I give you. And if you're going to make edits, you need it typed so you can just edit it, not have to completely rewrite it. Yes?
So when we're doing your rough drafts, do you want it like handed to you on paper, or do you want?
No, so we're going to submit it to School Sheet. Yep. So I can have it downloaded. I want to be able to download it. I'll make comments, things like that. On there. All right. Yes. No, the rough draft will now be due on Tuesday. Rough draft is due Tuesday. I do not even start on the final draft until I give you feedback. After I give you feedback, yes.
So, you know how we're doing this with partners?
Yeah.
Are we submitting both papers? Like, let's say my partner did one study and I did the other study.
I want you, so remember, my recommendation is that you do a Google Doc or you use your Microsoft Word account. Make one single paper. Now, with that one single paper, there's essentially going to be two halves, right? So the first half will be one of the studies, the second half will be the other study, but the idea is that you both read. One of you focuses on one, the other focuses on the other, but you still give feedback and push on each other's ideas, right? So that way you're engaged on both sides of it, okay? Does that make sense? Okay, we good there? What's your question?
I was just tripped up in the directions because it seems like a lot of the things overlap each other. Like there's a lot going on, but is all this what you just wrote in the Word?
Yeah, essentially.
So it only looks like 3 questions.
Yeah, 3 major ideas.
Oh. So like.
But like you need to be pulling all of your study design vocabulary into these things, right? So like in the observational study, you need to identify which of the studies is observational, and like a big part of that is what are the goals of the study, and then once you talk about the goals of that study, maybe in general, so an inference to a population, but also put it in the context of like what the actual sample and population and characteristic of interest were, then what did the researchers do to reduce bias? There should be a lot that you talk about there, and then there's a lot within study design about how you would improve that study. The same thing with the experiment. So like, there's a lot going on. Charlie?
How many paragraphs do you want?
I want you to completely answer these questions. So, here's the thing. A paragraph should have a main idea. So like, I would highly recommend getting used to not doing 5-paragraph essays. Like, if it needs to be a longer paragraph so you can cover one big idea, then do that. If you want to split it into like smaller ideas within a paragraph, like you can have a huge section, but make it 3 paragraphs with that one section. So like, if you talk a lot about, if you have 3 different ways that you want to improve the study and have a paragraph devoted to each way to improve that study, that's a good idea, right? But think about the sections overall. Does that make sense? Mm-hmm. Okay. I would probably have an overall introduction, overall conclusion, and then I would say 2 or 3 sections per study, but each section might have multiple.
Do you want introductions and conclusion for each study or for the total?
I would do it overall for the whole paper. Okay, so I'll need to collaborate on that. And that bell's about to ring in 30 seconds. So we'll come back, or right now, we'll come back, we'll start with the BYU and then get into 1.4 and 1.5.
She is tragic. Panic. Automatic attack.
Yeah, you did
Can I stop the camera? Ken Meister. Sir Kennington.
Overwrite that data, but I didn't want that data.
Can I stop the camera?
Yes, please stop the camera.